Hello, good evening. You guys can hear me?
Yes po, sir.
Okay. So, medyo madami-dami na tayo ngayon. So, okay na siguro yan. So, tagal-tagal na rin tayong hindi nagkita-kita. So, welcome. Good evening. So, we're here again, week 7 na para sa ating kinematics. We will be starting the module 2. So, to start with, okay, we will be discussing the Newton's second law of motion. Sandali lang, ha? Oops. Okay. So, Newton's second law of motion. So, alam natin na yung Newton's second law of motion consists of the very famous formula. Force is equal to mass times acceleration. Nung naisip to ni Newton, he is looking at one-dimensional equation of motion. Ngayon, alam naman natin yung motion is not one-dimensional. It can be three-dimensional, two-dimensional, three-dimensional. So pag-uusapan natin ngayon yung two-dimensional equation of motions natin noong mga nakaraang weeks tungkol sa rectangular, NT, at saka yung polar coordinates natin. So we will integrate this formula F is equal to ma doon sa mga pinag-usapan natin nakaraan na rectangular, NT, at saka polar coordinates tungkol sa position, velocity, at acceleration. So how are we going to do that? So first, doon muna tayo sa rectangular side. So alam natin na ang rectangular ang coordinate ang acceleration is a vector form in vector form. So pwede nating sabihin na yung total acceleration will be the sum of all vectors, let's say an x and y. So ang total force is the mass times the acceleration at at x and at y. So simple lang siya, no? So kung meron tayong rectangle, yung sum ng dalawang vector would be your hypotenuse, and that hypotenuse is the acceleration. So force is equal to mass times that acceleration. Okay. Let's try. Example. Can anyone help me read the example, please? Walang volunteer. Oh, sige. So, example. A man in a flatbed truck starts from rest up a hill at an angle of 10 degrees. If the flatbed is carrying 600 kg of freight in its back, and the static coefficient of friction is 0.3, what is the rate of acceleration at which we would expect the crate to begin to slide off the back of the truck? And how long will it take the truck to reach a speed of 25 meters per second at this rate? So let's do a vector diagram. So kung ito yung truck mo and you have a 600 kg weight at the back, meron ka ngayong different forces that are acting on this flatbed, on this weight. So tatawagin natin yung weight, tatawagin natin itong weight at 600 kg to be yung counter niya, siyempre ito at starting at rest. So everything is at equilibrium. So this truck itself is exerting a force equal to 600 kg, and it will be perpendicular to that body. So ito yung nominal force niya. So F at N, ito is acting on this vector. Now, this F of N has two components. Meron siyang F of Y at saka meron siyang F of X. Ito. F of X. Now, it's supposed to be, dahil dito sa vector natin, it's supposed to be, the direction of this F of X is going this way. Okay? Pero, sorry. It's supposed to be going this way. Ayan. This way. But opposite to this force, meron kang frictional force that keeps it from sliding. Okay? At meron ka rin acceleration going this way. Okay. Let's see. Summation of forces along the x-axis is equal to negative frictional force, ito yun, plus ito, 600 kg. Since the vector siya, di ba? So ito at 10 degrees, pwede nating sabihin 600 kg times 9.81 kg pa. Ito para maging Newton siya. 9.81 times sine of theta is equal to 600 kg times acceleration at x. Okay. We can call this as our equation 1. Summation of force along the y-axis is equal to force nominal, ito siya, minus, pabaliktad, 600 kg times 9.81. 9.81 is our gravity. Cosine 10. Since na it's a tres, 0. So here, makukuha natin F at N is equal to, ito, ililipat natin itong whole equation na to dito sa kabilang side. Calculate F at N is equal to 5796.6 Newton. Kung meron na tayong F of N dito, makakalculate natin yung frictional force, sabi doon sa problem, at 0.3 F of N. So frictional force is equal to 0.3 F of N. So frictional force is equal to, substitute natin ito dito, lalabas na approximately 1738.98 newtons. Since meron tayong frictional force dito, substitute natin ito dito sa equation 1 natin. Para dun, lalabas tayo na may iwan sa atin yung acceleration at x. So, acceleration at x is equal to 1738.98. Ito yun. Minus 600 times 9.81 sine of 10 divided by yon 600 equal to 1.19 meter per second. So which means, ang question dito, rate of acceleration at which you would expect the crate to begin to slide. So ito hindi pa siya nagsislide. So ibig sabihin minimum 1.19, mag-accelerate siya na 1.19. This crate starts to slide. So this is at 1.19 meter per second. So at 1.19 meter per second, ano naman daw, how long would it take for him to reach this velocity? So balik tayo dito. Acceleration is equal to velocity times time. Meron tayong acceleration na 1.19 meters per second. ito na yon, a at x is equal to 2.5 meters per second. O, tama ba? 2.5 pa. Ay, 25, sorry. 25 meters per second times time. So, meron tayong isang variable dito. We can calculate for time. Time is equal to 20.9 seconds. Question. Wala. Walang question. Walang question o walang nakikinig sa akin?
No questions so far po, sir.
Okay, no question. Naririnig nyo naman ako, no? Wala lang
Opo,
talaga
sir.
nagsasalita. Okay, narinig. So, etong lahat ng equation na to, ito siya in a more more neat form. Okay. Next. Oops. Next. So, ito yung example ng rectilinear coordinate. Rectangular coordinates. So, ginamit natin yung force times mass time. Force is equal to mass times acceleration. Yung acceleration, ginamit natin. We define them or we analyze them using rectangular coordinates. Ito na susunod is using normal and tangential coordinates. So, yung base natin parehas pa rin. Force is equal to mass times acceleration. However, meron ka ng curvature dito at meron ka ng angular momentum, angular velocity. So, ang ano natin, ang premise pa rin natin is acceleration is the summation of all its vector components. At here, ang vector components natin is yung normal, yung n vector, at yung tangential, which is our t vector. So, using our kinematics, yung nakaraang sa NT coordinates natin, alam natin na yung acceleration at the n vector is equal to velocity times the first derivative of your angle, or it is equal to the square of velocity divided by rho. Rho is defined as the distance from the center to the curvature. Okay? So, yung rho is from the center to the curve. So, kung curve mo, gano'n. Okay? Ang curve is laging sa loob. At yung acceleration at the t component is equal to the first derivative of your velocity. Okay? So, yun yung previous natin na na lesson. So, i-incorporate lang natin yung equations for acceleration into Newton's second law of motion, which is force is equal to mass times acceleration. So, ini-integrate natin o ini-introduce natin yung mass doon sa mga equations natin previously. So, example, a 2,500 pound car is traveling 40 feet per second. The car tires have a coefficient of friction with the road of 0.9. If the car is maintaining a constant speed, what is the minimum curvature before it starts slipping? Assuming the car is speeding up at the rate of 10 feet per second, what is the minimum radius of the curvature before it's slipping? So, ulitin natin yung drawing natin yung diagram niya. So, itong car daw nito is traveling at a curve rate. So, meron siyang frictional coefficient of 0.9. So, hindi pa siya nag-slip, no? So, which means nasa equilibrium pa siya. Hindi pa siya dumudulas. So, ang question dito is, ano yung minimum radius of curvature before it starts slipping? Before. So, ibig sabihin, hanggang hindi pa siya dumudulas. Kapag lumaki pa yung curvature niya, o lumaki yung curvature niya, it will start to slip. Okay? So, let's see. since the car is moving at constant acceleration, constant speed, acceleration is equal to 0. Constant speed kasi sabi niya dito, car, constant speed, there you go. Because it is at constant speed, acceleration is equal to 0. So, di-define natin. Una, yung force of friction natin. Force of friction natin, sinabi natin is 0.9 times F of N. F of N is our weight or nominal weight. There you go. So, nominal weight, ito, sinabi dito na ang weight ng car natin is 25 pounds. There you go. So, frictional force is equal to 0.9 times 2,500 pounds. Pounds. There you go. Okay. So, F of N, summation of F of N is equal to the force of F of N minus frictional force is equal to 0. Kasi equilibrium pa tayo. Okay, sorry, hindi to F of N. F of small n, ayun, is equal to F of N minus frictional force is equal to 0. Hindi pa siya nag-slip. Equilibrium pa siya. So, we could also say that frictional force is equal to MA is equal to, yung frictional force natin, 0.9 times 2,500 is equal to, at N side. At N side. Well, sinabi natin kanina na yung formula natin, at N side ito. Oops. Mass of 2,500. 2,500 times acceleration of 40 feet per second squared divided by rho. So, rho, nakukuha natin, is equal to 55.2 feet. So, yung distance ng curvature na to from the center is 55.2 feet. Question? Wala pa? So, sabi niya rin dito kanina na kapag binago daw natin itong acceleration, kanina meron tayo acceleration is equal to 0. If acceleration is equal to 10 meters per, not meters. 10 feet per second squared. Ano naman daw yung magiging curvature natin? Tataas ba o liliit yung curve radius natin from 55.2? So, pag binalikan natin yung yung vector diagram natin, magkakaroon tayo ito ngayon ng F at C. This is at velocity acceleration is equal to 10 feet per second squared. Okay. So, pwede nating sabihin na summation, bura natin ito ng konti para meron lang tayo ng space. Summation of force along the T, tangential, ito, is equal to F of N, ito yung car, times sine of theta, ito. Ito. Is equal to mass times acceleration at T vector. Summation of F at N is equal to Fn cosine theta is equal to mass times acceleration at n. Okay. FC, itong area na to, FC is equal to mass times ito at saka ito, acceleration at t plus acceleration at n. Ito at saka ito. Ito, FC. Pero ito, alam natin na this is a vector. So, ang tamang pag-add ng dalawang acceleration vector is equal to mass times at squared plus an squared raised to 1/2 square root. Tama. Since na FC is equal to F, ito, yun, kasi hindi siya nagsislip. So, meron pa siyang, equal pa siya doon sa, equilibrium pa siya doon sa friction force. So, we can say that FC is equal to FC is equal to FF. So, this is 0.9 times 25,000 is equal to mass is 25,000 divided by 32.2. 32.2 is yung equivalent ng 9.81 times quantity is 10 squared, 10 feet per second squared plus itong part na to 40 feet squared over rho raised to 1/2. So may iwan sa atin yung rho. Rho is equal to 58.8 feet. So kapag wala kang acceleration, kailangan mo lang ng 52.2 feet. Pero pag binilisan mo, ang rho mo dapat or ang radius mo dapat lumaki ng 58.8 feet para hindi ka dumulas, hindi ka mawala ng kontrol sa sasakyan mo. Question. Wala pa. O sige, kung wala pang question, present muna tayo. Chat box please, type present. Okay. So parehas lang siya, no? So yung kung ano yung ginawa natin dito, parehas lang siya dito sa sumunod na slide. Is just presented in a more neat manner. Okay, so ito siya at acceleration is equal to 0. Meron tayong 55.2 feet, which is yung rho natin o yung radius natin from the center to the curvature. Kapag ka naman acceleration is increasing to 10 feet, ang rho natin is at 58.8 feet. Okay. So next, last one. So ito naman ngayon is yung forces natin using polar coordinates. So kanina ginamit natin yung rectangular, tapos ginamit natin yung NT. So ito naman yun, magagamit rin polar coordinates. So sa polar coordinates natin, parehas pa din. Summation ng forces along the R vector and along the theta vector. Okay? Acceleration along the R vector or along the R line is equal to the second derivative of R minus R times the square of the first derivative of theta. First derivative of theta. Acceleration at theta is equal to 2 times the first derivative of R times the first derivative of theta plus R times the second derivative of theta. Okay, so ito yung galing sa natin, sa polar coordinate lessons natin. So yung A doon, yung equation ng A doon, pinapasok lang natin ngayon yung mass doon sa equations natin na nakaraan. So, example ulit. Ito. A catapult design consists of a steel weight of a frictionless rod, and the rod spins at a constant rate of 4 radians per second when theta is at 45 degrees from horizontal. The 30-pound weight is released from its position 2 feet from the center of the rotation of the shaft. Dalawang hinahanap. What is the force of the shaft exerts on the weight at the instant before and at the instant after it is released? And what is the acceleration of the weight along the shaft the instant after it is released? Okay. So, tingnan natin ulit yung vector diagram natin. So, ito yung vector diagram natin. Meron tayong 30-pound weight. Tapos, yung 30-pound weight daw is released at 2 feet from theta. Yung theta is given at 45. 45 nga ba? 45 degrees nga. Given at 45 degrees. The speed of its velocity is at 4 radians per second. Okay? So, meron... wait a minute, Give me a minute. Somebody's calling. Ay, nawala. Okay, balik tayo. Nawala yung caller. So, balik tayo sa problem natin. So, meron tayong r vector at meron tayong theta vector. So, let's look at the r vector first. So, summation of forces, summation of forces at r is equal to negative FR, yung frictional FR natin, itong FR na to, negative, minus 30 pounds cosine 45 is equal to mass times acceleration at R. So, acceleration at R, ayun, balikan natin tong formula na to. Oops. Acceleration at R is this formula. So, M times R double dot minus R theta, oops, pangit pagkakadrawing, theta dot squared. Okay. Sinabi rin natin dito na yung, ito baguhin natin to. Yung M, ipasok na natin yung 32. M is 30 pounds divided by, divided by 32 feet per second squared. Ito yung M, ito yung A. Etong R na to, second derivative of R, itong R is 2 feet. Ito pa ating second derivative niya, 0. Itong R na to, ayun yung R na yon. So, this one is 2. First derivative of theta, ito yung theta. First derivative is velocity. So, ito, 4. So, pwede natin i-rewrite. Ito ay negative FR. Oops, baguhin natin. Negative FR minus 30 cosine 45 is equal to 30 over 32 times minus 2 times 4 times 4 squared. Where FR, we can calculate FR is equal to 8.6 pounds. So FR, this is a 30 pounds. Ang force at the R direction or at R vector is 8.6 pounds. So let's get the sa side naman ng theta. Summation of forces. Oops. Summation of forces at theta is equal to F of S, ito yun, F of S, minus 30 sine, oops, bakit nagkaka-drawing? 30 sine 45 is equal to M A at theta. So, kuha natin yung formula ng A at theta. Balikan natin dito. A at theta ay ito. Okay? So, pwede natin sabihin na F of S is minus 30 sine 45 is equal to 30 over 32. Ito yun, same. Times R theta double dot minus 2 R dot theta dot. Okay. First derivative of R is 0. So, ito 0 na agad to. For, second derivative of theta, ang first derivative ng theta ay 4. Ang second derivative niya ay 0. So, 0. So, itong portion na to, magiging 0 na to. So, we can calculate the value of Fs. Fs is equal to, ito na lang maiiwan sa atin, 21.21 pounds. So, answering the question kanina, what is the force the shaft exerts on the weight at the instant before and after it is released? So, ito yun ngayon. Ito at ito. Question. So, sinabi naman, tinanong din dito, what is the acceleration of the weight along the shaft at the instant it is released? Acceleration along the shaft. So, acceleration along the R kasi ito yung shaft. So, acceleration along the R. Balikan natin tong equation na to. Ayan. So, since na the weight is released, so ito magiging 0. So, ibig sabihin, itong FR natin, FR is equal to 0. At the moment it is released, FR is equal to 0. So, if FR is equal to 0, balikan natin itong equation na to. Minus FR. Oops. Balikan na. FR is equal to 0. So, if minus FR, kunin natin itong equation na to, ha? Minus 30 cosine 45 is equal to 30, tama, 30 over 32 times R double dot minus 2 times 4 squared. So, itong 2 galing pa rin doon, itong 4 galing pa din doon. Itong 2, hindi na tayo 0 ngayon kasi ito na yung unknown natin. Ito ngayon yung naging 0 kasi at point of release. So, we can calculate this R double dot, or the acceleration along R is equal to 9.23 feet per second squared. Question. Walang question. Okay.
None po so far.
It's the same thing that we have discussed, only written in a more neatly manner. So, R double dot, tsaka yung FR, FS, tsaka yung R double dot. Just take note na ang kinuha natin is vectors. Hindi natin kinuha yung total acceleration. Kinuha natin yung acceleration at the shaft. So, kung wala nang question, homework due regular time na tayo. Balik tayo sa regular programming. Homework will be due on the 29th. And if that's it, then let's end early today. Maraming salamat.
Thank you po, sir.
Thank you, sir.
Okay, thank you. Thank you.
Thank you po, sir.
Okay, thank you.